Before you move identities to the cloud, security has to lead the migration. In this section, we'll connect three foundations: multi-factor authentication, conditional access, and identity protection, to the decisions that keep users, sign-ins, and applications safe. We've built the path from classic Active Directory foundations into the Entra ID identity model. Now we shift from understanding identities to protecting them. This section focuses on risk, access control, and stronger sign-ins, capabilities we'll rely on when we design migration and coexistence architectures next. In traditional AD security, trust often begins with location. Inside the network, joined to the domain, and protected by perimeter controls. Entra ID moves that center of gravity to identity and context. Access is evaluated based on who is signing in, how they authenticate, what device they use, where they are, and whether risk is present. That matters because work now happens across home networks, personal devices, and cloud apps. This is zero trust in practice. Verify explicitly, grant only what is needed, and design as if breach is possible. Multi-factor authentication makes sign-in safer by requiring proof beyond a password. That proof can be something you know, something you have, or something you are. In Entra ID, options include Microsoft Authenticator, FIDO2 security keys, passkeys, SMS, voice, and certificates. The key point is that not all methods provide the same protection. For administrators and high-risk users, phishing-resistant options are best. A successful rollout also needs clear registration steps, communication, and support. Choosing an MFA method means balancing security strength with user adoption. Authenticator push with number matching is often a strong default because it is familiar, mobile-friendly, and helps prevent accidental approvals. For privileged admins, executives, and high-risk users, FIDO2 security keys or passkeys should be the goal because they are phishing-resistant. SMS and voice can help during migration, or for users with limited device options, but they carry risks such as SIM swaps and social engineering. The best strategy is layered. Match methods to roles, compliance requirements, accessibility needs, and support capacity. MFA succeeds when enrollment feels predictable, supported, and low friction. Start by planning who must register, which methods are allowed, and when enforcement begins. Communicate early with clear instructions and visible leadership support, so users understand why the change matters. Then run a pilot with IT, admins, remote workers, and representative business teams to expose real-world issues. During rollout, monitor registration completion, failed attempts, and help desk tickets. When trends look stable, expand in phases and enforce MFA with fewer surprises. Authentication strength is how conditional access matches the sign-in challenge to the value of what is being accessed. A low-risk app might accept standard MFA, such as an Authenticator prompt or SMS. Sensitive data should require stronger methods, such as number matching or certificate-based authentication. Administrator access, privileged roles, and high-risk sign-ins should move to phishing-resistant options, including FIDO2 security keys or passkeys. The goal is not one flat MFA everywhere rule. It is defining the minimum acceptable methods for each scenario based on risk, sensitivity, policy, and compliance needs. Conditional access is the decision point for modern sign-ins. Instead of assuming anything inside the network is trusted, it evaluates context each time access is requested. Who is the user? Which app are they accessing? What device are they using? Where are they signing in from? Is there risk? Those signals are compared against policies. And when conditions match, controls are applied. That might mean allowing access, blocking it, requiring MFA, demanding a compliant or hybrid joined device, or restricting the session. The key idea is adaptive enforcement. Access decisions change with the situation, not with a fixed perimeter. Conditional access scoping comes down to two connected decisions: who and what is targeted, and when the rule should apply. Assignments cover users, groups, roles, service accounts, and the cloud apps being protected, from Exchange Online to Azure management. Conditions add context, such as risky sign-ins, user risk, device platform, location, client app, and device filters. The most important safety step is exclusions. Keep emergency access accounts available, avoid breaking service dependencies, and use small pilot groups or report-only mode before broad enforcement. Once a conditional access policy matches, the decision moves from evaluation to enforcement. Grant controls answer, what must be true before access is allowed? That might mean MFA, a compliant device, an approved app, or a stronger authentication method. Block controls are the hard stop, best reserved for clear cases like legacy authentication or prohibited regions. Session controls answer a different question. What limits apply after sign-in? They can shorten sign-in frequency, prevent persistent browser sessions, restrict downloads, or route activity through app control. Strong policies match enforcement to app sensitivity and sign-in risk. Conditional access templates are useful accelerators, not final designs. Microsoft provides common starting points, such as requiring MFA for admins, expanding MFA to all users, blocking legacy authentication, and protecting security info registration. The safe pattern is to deploy templates in report-only mode first. Then review sign-in impact, exclusions, break glass accounts, and application dependencies before enforcing. Over time, mature environments combine several policy layers: baseline protections for everyone, stronger controls for privileged access, risk-based responses, and app-specific requirements. Templates help you move faster, but validation keeps the rollout safe. Identity protection starts with a simple principle. Not every sign-in deserves the same level of trust. Microsoft Entra ID protection continuously evaluates signals like leaked credentials, impossible travel, unfamiliar sign-in patterns, malware-linked IP addresses, and anonymous networks. Those detections feed risk calculations for both the user and the individual sign-in. Risk is typically classified as low, medium, or high. From there, access can become adaptive, allow normal activity, require stronger verification, force a password reset, or block access when the identity appears compromised. User risk is a judgment about the account itself. Is this identity likely compromised? Signals like leaked credentials or confirmed malicious activity raise that concern. Sign-in risk is narrower. It evaluates one authentication attempt using contexts such as unfamiliar location, impossible travel, anonymous IP, or device details. The response should match the type of risk. A suspicious sign-in may trigger MFA or block access. A risky user often needs deeper investigation, password reset, session revocation, or containment, supported by logs and user reports. Automation is powerful, but it should never be switched on blindly during migration. Identity protection and conditional access can require MFA, force a secure password reset, block access, or route an event for investigation. Readiness is the key. Start with pilot groups, confirm the user experience, and verify support processes before enforcing policies broadly. Also confirm licensing. Conditional access typically needs Entra ID P1, while risk-based identity protection policies need P2. Your migration baseline should cover MFA, legacy authentication blocking, privileged admin protection, emergency access accounts, and monitoring. Track each control as not started, pilot, enforced, or monitored. The main takeaway is that Entra ID security rests on three connected capabilities: strong MFA, conditional access, and identity protection. Together, they protect sign-ins, adapt access decisions to context and risk, and speed response when compromise is suspected. In Module 3, we'll use these foundations to evaluate migration strategies and choose the right cloud, hybrid, or coexistence model.